Assalamualaikum everyone. Today we would like to present about FET. Before we start our presentation, let me introduce myself and my groupmate. My name is Putri Nur Alia binti Khairuddin, and then we have Muhammad Nur Syauqi bin Muhammad Zaki, Dalila Nur Farah Harina binti Makiong, and lastly Muhammad Hafiz bin Makrani. Let us proceed to question A. For question A, it required us to use our own word and diagram, explain the type, basic structure, symbols, and the operation of FET. What is FET? FET is field effect transistor, and it is a type of transistor that uses an electric field to control the flow of current in a semiconductor. FETs are devices with three terminals, which is source, gate, and drain. FETs control the flow of current by the application of a voltage to the gate, which in turn alters the conductivity between the drain and source. Let me explain about source, drain, and gate. First, source. Through which the carriers enter the channel. Conventionally, current entering the channel at source is designated by IS. Second, drain, through which the carriers leave the channel. Conventionally, current entering the channel at drain is designated by I. Drain to source voltage is VPS. Third is gate, the terminal that modulates the channel conductivity. By applying voltage to gate, one can control IP. Okay, so we will move to the types of FET that will be presented by the next presenter.
I am Dalila Nur Farah Harina. In my part, I will present about types of FET. The first is the junction FET or JFET uses a reverse bias diode junction to provide the gate connection. The structure consists of a semiconductor channel which can be either N-type or P-type. A semiconductor diode is then fabricated onto the channel in such a way that the voltage on the diode affects the FET channel. In operation, this is reverse bias, and this means that it is effectively isolated from the channel. Only the diode reverse current can flow between the two. The second type is MOSFET. MOSFETs are widely used in many areas of electronics and particularly within integrated circuit. The key factor of the MOSFET is the exceedingly great high impedance these FET are able to provide. That said, there will be an associated capacitance, and this will reduce the input impedance as the frequency increases. The next type is MESFET. The MESFET is the metal silicon FET is normally fabricated using gallium arsenide and is often referred to as a gas FET. MESFET are used for RF application where they can provide high gain low noise performance. One of the drawbacks of GASFET technology results from the very small gate structure, and this makes it very sensitive to damage from static ESD. Great care must be taken when handling these devices. The next type is HEMT or PHEMT. HEMT is the high electron mobility transistor, and piezoelectric high electron mobility transistor are development of the basic FET concept, but developed to enable very high frequency operation. Although expensive, they enable very high frequencies and high level of performance to be achieved. The next type is FinFET. FinFET technology is now being used within integrated circuit to enable high levels of integration to be achieved by allowing smaller feature size. As higher density levels are needed and it becomes increasingly difficult to realize ever smaller feature size, FinFET technology is being used more widely. The last type is VMOS. VMOS stands for vertical MOS. It is a type of FET that uses a vertical current flow to improve the switching and current carrying performance. VMOS FET are widely used for power applications. For the next slide will be presented by Muhammad Nur Syauqi.
Okay, for the operation of FET, consider an N-type semiconductor simple bar. It is known as an N channel, and it is electrically equal to a resistance as illustrated. The external connection is then made by adding ohm contacts on each side of the channel. As a result, when a voltage is placed across the bar, current flow through the channel. The terminal from which the bulk of carriers electrons enter the channel is referred to as the source, and it is denoted by the letter S. The terminal by which the bulk of carriers exit the channel is known as a drain, and it is denoted by the letter D. Electrons are the predominant carriers in an N-channel device. As a result, the channel operates similarly to a DC voltage VDS applied across the resistor RDS. The drain current ID is the resultant current. When VDS rise, ID rise correspondingly. Next, we go question B. As a figure, explain the construction and characteristic graph of JFET in terms of different type of structure. I pass to Mama Hafiz bin Makrani to present.
Okay, that is my part. Consider a sample bar of N-type semiconductor. It is called N-channel and it is electrically equivalent to a resistance. Okay, ohmic contacts are then added to each side of the channel to bring the external connection. Thus, if a voltage is applied across the bar, the current flow through the channel. The terminal from where the majority carries electrons enter the channel is called source, designated by S. The terminal through which majority carriers leave to the channel is called drain and designed by D. For a N-channel device, electrons are the majority carriers. Hence, the circuit behaves like a DC voltage VDS applied across a resistance RDS. The resulting current is the drain current ID. If VDS increases, ID increases proportionally. This is JFET characteristic. In above I minus B image, we can see the graph for three different values of VGS voltage: 0 volt, -2 volt, and -4 volt. There are three different regions: ohmic, saturation, and breakdown region. During the ohmic region, the JFET acts like a voltage control resistor, where the current flow is controlled by voltage applied to it. After that, the JFET get into the saturation region, where the curve is almost straight. That means the current flow is stable enough where the VDS would not interface with the current flow. But when the VDS is much more than the tolerance, the JFET get into the breakdown mode, where the current flow is uncontrolled. That's my part. Thank you.
Question C is provide one calculation example for any JFET configurations. Calculation example is given determine ID and VGS for the JFET with voltage divider bias in figure 1 given that VD equals 7 volt. First thing first, you have to write the formula for ID. ID is equal VDD minus VD over RD. Then we will get 12 volt minus 7 volt over 3.3 kilo ohm. Then you have to simplify and get the answer is 1.52 milliampere.
To find VGS, we must have Vs and Vg. The formula for Vs is equal to ID multiplied by Rs, and the answer that we will get is 2.74 volt. The formula for Vg is VDD divided by R1 plus R2, and we will multiply this with R2. We will get 1.54 volt. For we to get the VGS, we must use Vg minus Vs. The final answer that we will have is negative 1.2 volt. If you have carefully watched our presentation, you will hopefully have a better understanding of FET. That's all from us. Thank you.